Nice meeting you all again, and happy healthy day. Today, we're going to study on an interesting topic on starting of an engine. Now, what is the starting of an engine? So, last lecture you explained about admission of fuel, the common rail system, and then we went on to unit injection system and so on. Now, what is this and what is that? There, we admitted the fuel, we extracted the energy from the fuel and made to run the engine continuous throughout the voyage. But here, it is the initial start. See, always, we all know, we have a starting problem, isn't it? Everyone will accept starting problem. So, how to start it? When an assignment is given or when a project is given, we say, so where to begin with? Yes, here. The same way with this engine. How to start it? Now let's go to the basics. We all know, you are having a bicycle. Then you would have, you would be riding maybe a motorcycle. And then some would have experienced riding of a car. Now, how you make this bicycle move? We all know there is a pedal. You stamp on the pedal and stamp on the pedal. And when you stamp on the pedal, what's happening is there is a chain which is connected to the sprocket wheel, to the rear wheel. It is connected and which is making it to rotate. And that's the way you are cycling. Okay. Now the next bike, water bike. Whether it's a 2-stroke or 4-stroke or whatever, it is a bike. How was it in the good old days, maybe about 30 years back, like Rajput bike? Those days, Rajput bike was very famous. How did we start this bike? We just moved the start lever down and we pedaled down and then we pressed on it. We gave an initial 2 kicks. We didn't know why we are giving that initial 2, slow kicks. And then we were told to do it, so we did it. But there is a meaning, and that's where I'm coming to. We pedaled it, and then we gave a firm kick by accelerating the fuel, and the engine started. Now here, can you tell me what was happening here inside this? When you did the pedal kicking, what was happening was, when you pressed that pedal, which had a sprocket arrangement, gear was engaging on a wheel. It's called as a flywheel. Now in a 2-stroke engine where the flywheel is, in a 4-stroke engine where the flywheel is. It engaged in the flywheel and made that engine to rotate. Now you may ask, sir, you said last class, we given fuel when the compressed air has reached from 450 degrees centigrade, the fuel burns spontaneously, pressure built up and pushed the piston down. The piston, when it is pushed down, which is connected to the connecting rod and the crankshaft was made to rotate, that is the reciprocating motion converted into a rotary motion, and the propeller shaft was rotating, and you had a propeller which was made to rotate, push the water behind, the ship moved forward. Now, what is that we are making the engine to rotate? Yes. Initially, we are giving it a up and down movement. Why is this up and down movement? Why is this up and down movement that you have to do? Straight away, you can just, in a standstill engine, can you just give the throttle and put the fuel inside and say, start, will it start? No. You have the fuel. What did I say? The air inside the cylinder must reach the spontaneous ignition temperature of the fuel, and then the fuel burns. The fuel what you admit inside burns. Now, initially, the air was atmospheric air temperature, which was 45 degrees centigrade. It's the summertime now. We all know it is about 45 degrees centigrade now. In winters, in the month of December, this may come down to 18 degrees centigrade too. This temperature, this air temperature must be raised to 450 degrees centigrade, and then you admit the fuel. That is what you're doing it in the beginning, the starting. What do you do when you take the pedal, starting pedal, and then give it 2 kicks? You're making the piston to move up and down, compressing the air and making the air to reach the spontaneous ignition temperature of the fuel. That's what you're doing. That's what you're doing. Okay. Now here in the bike, I said you do a kickstart. Okay, can we adopt the same kickstart in the ship's main engine and make the flywheel to rotate? Is it possible? No, it's not possible. You cannot just push a wagon flywheel and turn the flywheel with your hand. No, it's not possible. Such a huge 100 tons weight is a crankshaft. You have to make it rotate. So you have to have a different mechanism. What mechanism is that? Now, let's come, for example, to the Honda bike. Nowadays bike. Let's take the older bike I told you now. Nowadays bike. Are you doing the kickstarting? You are not doing the kickstarting. What do? Instead, you sit in the bike. And you ask your lovely girlfriend to sit behind you. And then you press the button. You just press the button. And as you press the button, what's happening? Some sound develops. Some sound is coming. Sound is coming. When sound comes, what is it? This electrical power from the battery is going to the self motor. It is charging the self motor, making the self motor to rotate, the armature to rotate, whereby there is a gear called Ventex gear, which is spring loaded in the forward. As it rotates at a very high RPM of 1000 RPM, this motor, as it is being rotated, this Ventex gear, due to the centrifugal force, it moves forward and gets into the flywheel grip. In the bicycle, I'm still not coming to the ship's one, I'm still talking about the motorcycle. Nowadays motorcycle. It engages and turns that flywheel, and the piston moves forward and up and down and up and down, and the air is getting compressed, and at the right time you admit the fuel, the engine starts. Once the engine starts, now tell me, all of you tell me, you have ridden and started bikes and cars and all. When will you stop this switch, taking out your hand from that switch? When you know that the engine has picked up speed, sufficient speed, then you take out your hand from the press button. Yes, that's the right thing to do. If you don't take it out, what happens is the engine is started with fuel. Also, you are giving the battery power, so the engine RPM will be higher. It will overtake the battery power, and you will damage the starting system. Self motor, you will damage the self motor. So you have to take out your hand at the right time. It's made much more comfortable nowadays. It's made much more easier for us. Okay. Shall we adopt the same system to our marine engines? Starting? We can, but there is drawback. We need a bigger battery, a larger size battery to energize the self motor, to engage it onto the flywheel, which they found it was not comfortable. The cost involved. See, anything you do on board a ship, you have to have this in mind. You are not ordinary engineers just to work blindly what is given to you. Economics, it goes on economics. What you invest and what you get out is economics. Here, keep that in mind. The designers, the owners said, no, by investing a big amount on the batteries, it's a big loss for us. Try developing something new. Engineers like you, some are good designers here. I tell you, some will be a good designer, will get into designing, some will be sailing on board ship as chief engineers and so on, some will be a superintendent, some can also become a ship owner too. It depends upon your capability and capacity. Now, here the designers started developing a system where, what was our thought? make the piston move up and down. Why you should make the piston move up and down? To reach the spontaneous ignition temperature of the air. That is all the aim. What they did, they used air, compressed air, at a pressure of 30 kg per centimeter square to push this piston down. To push this piston down. When they started pushing the piston down, one piston went down, the other piston was connected through the crankshaft, through the connecting rod, and the other piston was coming up. And this way, first cylinder, as per the firing order, now watch this very carefully. Again, I am coming to the firing order. 1, 5, 3, 6, 2, 4. You admit the air 1, then go for number 5. 1, 5, 2, 6, 3, 4. You start admitting one after another. The engine picks up momentum. That is called as sufficient speed. Sufficient speed. The first requirement here for a starting a system to start this engine is they use this compressed air. Now, where do you learn about this compressed air? In your marine auxiliary dictionaries, you will learn about air compressors. Now, what is this air compressor doing? Supplying air for only control systems and so on? No. For your starting of the engine, when you have two main air bottles, you fill up the main air bottles to a pressure of 30 kg per centimeter square and use that air for starting of the engine. Now watch this. You are not using this air during the entire voyage for starting. You are only initially using this air for starting of the engine, and then after the engine has picked up momentum, as you take out your hand from this button, starting air button from your bike, you take out, the same way here, the air is cut off. The air is cut off and shut and kept as reserve. The engine now runs on fuel. Next. Second point, the second point is, for a good starting system, you should have a correct compression ratio. Compression ratio. What is this compression ratio? If the compression ratio is not sufficiently high, the final temperature of the compressed air charge, you see here, again I am talking about final temperature of the compressed air. See, the temperature of the air only matters, because that air temperature should reach the spontaneous ignition temperature of the fuel. Okay? Will again be too low for ignition. Compression ratio can become low in old engines due to bearing wears, retracting engine fans, closures, barrel wears, and incorrect timings. Yes. No. In a brand new engine, the barrel clearances between the connecting rod and the crank pin, if you put a feeling engine, check it, it will be around within the limit of 0.12 millimeters and so on. But as the day goes on, there is a wear and tear in the barrels. So what happens is, the piston with the connecting rod, they drop down a little bit because of the wear. They drop down a little bit. The space, the compression space becomes more. When the compression space becomes small, the ratio, that's called as ratio, is lower. That's why in a brand new engine, starting is very easy. As the engine becomes older and older, because of this wear, the starting, it takes a little longer time. Now, that is not the same in all the all ships, in all the engines too. It depends upon how well you maintain it. If you can remove the bearing in the period given, then of course it's going to reach its original compression ratio. So then you can start the engine in the right time with a very minimum RPM. Next slide. Here, methods of start. How many methods? Four methods are done. First is hand starting. Come on, let us give an example for hand starting. In our native places where agriculture takes place, there is a small engine. And that engine, what do you do? Do you have a battery and all these mechanisms? Can that farmer afford to spend so much? No. He's given a single cylinder engine with a wheel, hand wheel, and he puts that hand wheel and he rotates. And he rotates harder and harder and harder. And then once the momentum and is picked up, he switches on the decompression lever and removes this hand lever what he has used for turning. He removes it, the engine starts. Engine starts because the air temperature is reached, the spontaneous ignition temperature, and the fuel is admitted, and it starts. That is hand starting system. Can we adopt that hand starting system for the rain? It's not possible because this engine is a very big engine. The piston diameter alone is 1 meter diameter. There, the farmer, his engine, piston diameter is approximately about 2.5 inches. 2.5 inches to 3 inches, that's all. Here, it's 1 meter diameter. Okay, next, electrical starting. I gave you a very good example for electric starting with regards to the bicycle or motorbike. Electrical starting with the battery in it. That goes. Oh, hydraulic starting. Here we have to give it a thought. Why we have to use hydraulic starting? Or where do we use this hydraulic starting mechanism? Now, gas carriers, tankers, the ships which are handling these gases in a liquid form. It's a very dangerous, a ship which carries a very dangerous cargo. I tell you, this pen, I'm not allowed to use it on a gas carrier. This pen should be made of brass, or the tips of the pen, if it touches the floor on the deck, on the main deck, where the gas is there in the big storage vessels. And if there is a small leak, microcandle power is enough to blow the entire ship. You would have seen it, your mother using the gas cylinder, this small 14 kg gas cylinder at home when she did some. Have you tried it? Yes, we all have tried it. What happens? We have the ignition switch here and we open the gas, and when we press the trigger, you would have seen how the flame charges. It charges, boom, it charges. It charges. It is not burning there, took the gas. It is just charging, boom. That means if you open this gas more and delay in your ignition, then it may also reach your hand or even your face. That's how many people lose their life by mistake opening up this fellow and then going and taking one matchstick and coming here and trying to light it. Oh no, you don't do that. Never think of that. Now, that is the place where you use hydraulic starting system. Hydraulic starting system. And this hydraulic starting system is mainly used for emergency generators, which is kept in the aft of the deck, where oil, the pressure, it is kept under pressure. Now, you may ask, sir, hydraulic oil, how does it start, sir? I will explain. Hydraulic pump is there to pump the oil under pressure. You keep it in a pressure cylinder and you open a valve. When you open a valve, it goes and operates a piston, and which is connected to a rack and a pinion method. It is connected to a rack and a pinion method. When the rack is pushed by this piston, the pinion rotates. When the pinion rotates, it goes up, engages on the flywheel, and the engine is made to rotate. And the air temperature there, the air is getting compressed in the cylinder, and the air temperature reaches spontaneous ignition temperature, and the fuel is admitted. That is how it is. Now, air system. Yes. This big a main engine which is developing 1 lakh bhp. Now our bike is only developing a very small bhp. Our car may be about 10 bhp. I am talking about 1 lakh bhp. 1,50,000 bhp engines are there nowadays. And if that kind of an engine has to be one-cylinder engine, which is about 3 to 4 stories height, if you want to start, then you use air starting system. Yeah. Now, anywhere and everywhere, there are some regulations which are governing us. There is something called SOLAS. It's safety of life at sea. This regulation says how much quantity of air should be available in this air bottles to 2 air bottles is, according to the rules, air stored in air reservoirs is sufficient for 12 stars of reversible engine and 6 stars for non-reversible engine. What is this reversible engine and non-reversible engine? An engine which rotates only in one direction is called as, non-reversible engine. You should have minimum 6 stars of air. Now, if you have an engine which can be made to rotate clockwise, stop, then made to rotate anti-clockwise, for such engines, you must have air sufficient enough to start this engine 12 times. 12 times. Now, you may ask, sir, can you give an example for this reversible engine and non-reversible engine? Yes. Our slow-speed engine, which is directly coupled to the propeller and the propeller shaft, with the propeller fitted in direct, it is the reversible engine, which can be reversed. You can stop, you can run it in the head direction, then bring it to stop, then once the propeller comes to a standstill, then you can run it in astern direction. Now, non-reversible engine, where CPP, control pitch propeller, is there. This propeller, what I say, is control pitch propeller. That means each blade, maybe, there are in some propellers there are 4 blades, some propeller there are 5 blades. Now, these 5 blades in the first side is fixed. One single piece, all 5 together, one single piece. Metal, one single metal it is made. But whereas here, non-reversible engine, it is made in different, bits by bit. Each fin is made, each blade is made separately and fitted, where it's called as controllable pitch propeller, where you can change the pitch direction. Direction of pitch can be changed. By changing the direction of the pitch, you can run the engine in the head direction, that is, taking the water from the forward and pushing it behind. Also, you can run the engine in the astern direction. It can move by taking the water from the astern and pushing it forward, and then push it to the astern. The engine is running in the same direction only. The propeller is rotating in the same direction, whereas the blade has changed its angle. That is all. Each blade has changed its angle. Now, I have given a very good example for a non-reversible engine and a reversible engine. I did speak about admitting of air as per the firing order. We all know if there is a 6-cylinder, 2-stroke engine, that is 360 degrees divided by 6 is 60 degrees. Okay, angle for each cylinder. First 60 is for number 1 unit. Next is for number 5 unit. Next 60. So 60 plus 60 is 120. 120 plus another 60 is 180. And it goes on 360. All the 6 units are covered. Now 0 to 60, when I admit the air from 0 to 60, then from 61 degrees onwards, if I go to number 5 unit, what's going to happen is 0 to 60 when I admit in the air, at the 59th and 60th moment when I'm shutting off the air for that one, the first cylinder, as per the firing order, the air is getting shut off because I don't need any more air there, and I want the air here at number 5 unit. Now, when I shut the air at number 1 unit, the engine RPM will reduce. Now, just think, what was our intention to give in air? To make the engine piston to move up and down. That is the reciprocating motion into rotary motion and rotary motion into reciprocating motion. We wanted, we got it. If that was the intention, why did you slow down there? Is it worthwhile slowing it? And again coming to number 4 unit and starting to admit air from beginning? No. Now what you do is, you are something called overlap period, when before you could reach the end of number 1 unit of admitting the air, terminating the air, you start off maybe a couple of degrees earlier in number 5 unit. In number 5 unit, you start giving air. So, the same momentum is picked up, the same RPM is maintained, and here it takes over. It takes over. Another good life example, baton relay. You all do baton relay. How does it start? 400 meter baton relay. The first starting guy, he says, okay, he's got a gun waiting there to shoot. Saying, on your mark, and say, go. Okay, the moment he says go, the bat is there in my right hand. I take the bat and I'm charging. How many meters do I charge? 100 meters, because it's a 400 meter relay. Every 100 meters, I've got the other guy waiting to receive the bat and then to pass it on to the next. Now let's take, for example, the first guy is coming. I'm now the second guy. Okay? Now I'm the second guy. Here is my line here. Shall I wait for the line here and then ask him to come next to my line and then take the bat and then start off? No. What I do? I look at that guy and see at what speed he's coming and start off maybe about 20 to 30 feet earlier itself. Before he could reach me here, I have started my speed. I've started charging. I've started running. When I start running, I tell him, come on fast, give it. He comes fast and then he hands over the bat approximately about 30 feet. Away from this line, I move off. He hands over the bat line, moving with that. What I have done now? He is been running at maybe 50 kilometers per hour speed. When he comes here and he has to hand over the bat to me, he has to drop down to zero, hand over the bat, and then I have to start from zero and reach that same 50. It's not worthwhile doing that. Meanwhile, I pick up the speed to 50, make sure he's coming closer, I take the bat from him without slipping it out, I take the bat from him, so the speed is maintained. The speed is maintained. 50 he was running, he crossed at 50, he handed over the bat at 50, I took over the bat at 50 only, because I've already moved myself, started running and picked up my momentum to 50 kilometers per hour speed. The same way, I did not lose the speed. Same way here, you have to time it and give an overlap for the engine not to stall and then restart. They'll stall and then start again to rotate. This is the beauty of having this overlap period. Next. Okay. Now, let's come up with the basic, air starting system. I just say, okay, admit air in number 1, sir. Then admit air in number 5, sir. This is what we have to do. But can we just blindly have one valve and just have one pipeline arrangement to push it in number 1 and then shut it, then put this fellow over and then close that guy and go on? No, we can't do that. We have to have some additional mechanisms which could make things easier on board a ship, because every person employed on board a ship is going to cost the company a lot. So that's why these automatic systems have come. And with these automatic systems, they came up with the simple air starting system. It's a simple system, the starting air system of an engine will contain the following. That is, it will contain you call it as a relay valve, or you can call it as a master valve, or you can call it as an automatic valve. I will show you in the diagram where it is located, don't worry. The next is it should have a pilot valve. The third point is it should have a distributor to distribute. Distributor, the word itself says distributor. Oh, then it is to distribute. To whom? Number 1, number 5, number 2, number 6, number 3, number 4, like that. It should distribute. So that is why you call it distributor. And the final point is this air starting valve, which is mounted on the cylinder. Now, just not having a simple opening there, it's got a valve arrangement. It opens, again, the air is making it open, and as soon as the air pressure drops, it should come back to close. That is the mechanism with this air starting valve. Now, the basics of force engaged, like warships. Warships, he may be an engineer, walking inside the engine room. As soon as the war has started and you have to hold the guns, this engineer also leaves the engine room and he goes up and holds the barrel. So you had enough manpower. So it was the Indians, the study method, they tried with manual. Things were going on fine. But human beings, we are not human beings. We become tired. Sometimes, maybe the previous instance or the past, the future is running within us. We may make mistakes. It may, mislead us. We may make a mistake in the time of opening. Maybe for instead of a couple of seconds, 5 seconds, you may open for 6 to 8 seconds more. That can happen. So, they were damages to the engine. To avoid that, then they came up with, a mechanism with air-check systems, air-check parts. Later they found, even this was not that satisfactory. They came up with the pilot operated either individual or rotary distributor. And finally, I would say, the present, they have a distributor that is engine with one direction of rotation. Engine with one direction of rotation. They have equipment called distributor. Thank you very much. I think I will continue with this in the next hour. As time permits. Wish you all the best. You have paid good attention, but come up with doubts. I want you to ask questions. It keeps me engaged, and we are industrial experienced people here. Come all the way from the industry to interact with you and to equip you to all kinds of systems there on board a ship. Thank you.